Okay, for Lab 2, one item we should go over now that we have a conceptual model built into our site and a correctly oriented site is energy analysis for simple masses. So with that, my mass is not necessarily complete. I want to have this building connected. So I just wanted to go over some simple ways of manipulating your masses and making sure that they line up and they're correctly modeled for an energy analysis. So I have made all my shapes in one mass. So when I click on it, I get the option to edit in place, which is what I will do. And I want these two pieces to be attached together, as they're all going to make one building. So if you've used a lot of AutoCAD in the past, the offset tool was kind of how you move things around and placed lines. In Revit, the offset command is more or less the align tool now. There is an offset command, but the align tool is the tool that you're going to be using both in 2D and 3D, pushing shapes around and making sure they align correctly. So here on our Modify tab, we have the align tool, where you can type AL. And when you select it, you always select the face you want something to go to, and then what you want to bring there. So in the case of these masses, I can move this face. I can align face to face and bring them together that way. You might find when you're modeling masses separate from each other, they're slightly not parallel and they won't even out with the align tool. What you can do if that's the case is you can also align actual individual parts. So if I go to the align tool, click align, select the face, and use my tab to tab through and select one line and click on it, you'll see it aligns that line to the face of the mass we're going for. I can do that again, therefore making sure that this wall is exactly parallel to the mass I'm attaching it to. For now, I'm going to finish this mass so that we can start the energy analysis. So, a couple things you have to do. One thing is you should differentiate between existing and new modeling. When you jump into a file and just start modeling, it's going to tend to put it all into the new construction phase. So what we're doing here is we're going to differentiate between the existing and the new, or the existing and the new. So I am going to look at it from the side, select everything, and you'll see really most of the data goes away. But phase created, everything selected is being created in the new construction, which is not necessarily what's happening. Our site and the existing buildings are existing. So I'm going to flip this to existing and hit apply. And you'll see it grays everything out. And when you select on pieces and scroll down its properties, it's listed as existing. Now one thing we don't want existing is our new building. So we can select that separately and flip that back to new construction. And you can see everything is grayed out except for our new building. This way at least Revit knows this is new and this is old. The next thing we need to do is give our building floors or levels. And to do that, just make sure you have actually drawn your levels where you think you roughly need them. They can always move. It's all parametric. You move these, they'll change the mass. But remember that you have to have these drawn in order for this command to work. Flip back. And then you select the mass, and then with the Modify Mass tab, you'll see Mass Floors. If you click that, it's going to ask you which ones you want to mass. We want to do, let's say we want to do these three. Okay. And it looks like only a couple actually hit my mass. So what I can do is you can always modify it by clicking Mass Floors again and say I want the fourth floor too. And now I have a fourth floor. And obviously, if you ever want to remove floors from a mass, it's simple as clicking and then removing one of these. But now we have a mass, we have floors in that mass, And what we're going to do is we're going to go to the Analyze tab. Now I have some plugins on this version of Revit that your Revits won't have, but these are free plugins that I recommend, and we can go into those separately in another class. So what we want to do now is let's check our energy settings, because we want to make sure this is set up properly first. So click on Energy Settings. I will save my project. And what you want to do is make sure your building type fits the type of use that you're doing. In this case, school or university is correct. But if we were, you can see there's a lot of other options for building type. And that's just determining how often are these typically used. For example, school or university, it's probably assuming either a 12 hours a day, 5 days a week, or 12 hours a day, 7 days a week use. And similar, all of these other pieces will have uses like that built into it, and a lot of assumptions. The assumptions might not be completely correct, but they're close. And as long as you don't change these uses between one scheme or another, you can compare your schemes to each other and make sure and see the differences that the masses do. So make sure your ground plane is on the correct plane. In this case, my ground plane was renamed to be ground, so that's the right level that we need. Export category. That doesn't matter yet because we are not exporting a detailed model. We're doing an energy model, and our analysis mode is going to be conceptual mass, because we don't have any walls yet. If you have walls and rooms, you can start using these other analysis modes, but for now I'm doing conceptual mass. And you can see it makes some guesses. Target percentage glazing, 40%. You can up this, you can lower this, and it'll just change the way that the glass to solid wall ratio is throughout the project. And again, it's going to just be every wall. You can't really decide which ones are which. And then you can also click on your conceptual constructions, and it'll tell you roughly how everything's being built. Again, these are all very schematic and not very detailed. But if you keep them all consistent, then it'll be consistent throughout your project. So with this, I'm going to hit OK. Now, one thing I want to do before I run the analysis on this is I'm going to click on my mass again, click Edit in Place. And one thing you want to do is make sure if you're touching masses together, make sure you use the join command. Join them together. And what that does is it won't double count this wall that is connecting the two. Now the exterior envelope is just the outer faces of this and this L. It's not going to double count in here when you run the analysis. So that's important to do to make sure your masses are joined together. Go back to Analyze tab. We're going to say Show Energy Model. And you can see right now what it did was very simply added 40% glazing onto all of your rooms. Or your masses right now, because we don't have rooms. So that's as dumb and simple as it gets. And now we're going to run our energy analysis. Everyone should have an Autodesk sign-in. It's free if you're in the education world or a student. So if you don't have one, go ahead and sign up, and it'll allow you to run some of this analysis. So what it's doing is it's asking if I want to create this. This uses the Green Building Studio engine. It's asking me what to name it. If you already have an account, you would see a lot of different runs on Green Building Studio that you could pick from, but this is a new project and we want to run it for the first time, so I'm just going to create new. So then I'm going to use all of the energy settings that you selected and use your mass, and this is all cloud-based, so it's going to run some analysis. You'll see their computer is not doing anything. It's all doing this via Autodesk's server farm out somewhere. And then you'll have a pop-up that comes up in this bottom right that says your analysis is done and you can review the results. So I'm going to pause this until that comes back, and then I'll show you the results. Okay, once your results are complete, you can either click on the hyperlink that comes up here, or you can come up to results and compare. In this, it'll give you some basic information about your model, and it'll give you some energy results. And again, a ton of assumptions were made about this model. I actually have 2 runs in here, so I'm going to delete one so you can see. This is the most recent run, and it gives you some basic setup of where you are in the world, their location, the weather station they're using, the floor area of the building you're designing, the exterior wall area, so that gives you a very quick floor to area ratio, or volume to surface ratio. And then it gives you some assumptions for lighting power that's based off the school or university. The amount of people in there is always very high, but again, that's based off of a lot of assembly spaces, assuming every space in your building is a school or university space. And then it tells you how many BTUs a year you're using roughly, and it gives you some graphs showing carbon emissions, energy type. It normally assumes fuel for heating, electricity for cooling, and lighting, obviously. So you can go through all of the data that comes through. And again, don't dive too deep into this because this is still very schematic, but you can use this to compare different schemes to each other. And this just can be exported as a PDF. There's also, if you come down to the very bottom, you have your annual win-rows. And that doesn't change no matter what scheme you're on. That's just showing what your site is like. And then your monthly win-roses. So this is all very good data for understanding how does the wind work in this area. And then all of your annual temperatures and even your humidity points. So this is all very useful data for reviewing. And up on top, you can easily compare one conceptual shape to another in terms of energy use. And that is the simplest way to do a conceptual model, or a conceptual energy model, starting with just some simple masses.